Hey everybody, welcome back to the Adventures of Blink. I am of course Blink. You can find me on GitHub right here. So today we're going to continue season 2 as we explore how to build an app using a bunch of DevOps tools. And the app I've chosen is something very small and simple because I want us to focus more on the how we do it than on the what we're building. But I wanted us to still have something that was a little bit of fun, a little bit of interesting kind of coding along the way. So we're going to play the game Hangman. Now, if you're not familiar with Hangman, it looks kind of like this, and the idea behind Hangman is a word or a phrase is chosen, and all we see is the number of characters and the number of words on the screen. And then as we guess letters, if the letter appears in one of the spots, then we add it to the spot and we're trying to complete the word or the phrase. But if the letter doesn't appear, then it causes us to draw another line in the hangman board. And once we've got the complete board built with the little guy hanging from it, then that's the end of the game. You lose. So the idea is that you need to figure out what the word is before you run out of letters and your little guy gets hanged. So that's what we're going to do. It's a very simple game if you think about it, not a whole lot of moving parts, but we're going to sort of build this with some overkill involved. All right, so let's see if we can map out how our app's going to be built. To get started with, the first thing we're going to need is a database. So the database is going to live here, but we're not going to build the database directly on our system. We're going to build it in a Docker container. So I'm going to put a little M over this because it's a Mongo DB. And then we're going to wrap that in a Docker container. So there we have Docker. Okay. Now, if you know much about Docker already, you may have already watched the previous episode and talked through some of the basics there. Docker containers are read-only, which is not a good look for a database, which means we're actually going to have to store the data in an external volume. Okay, so there will be a Docker container that will contain our database config. It'll make it easy to spin it up and get it started, but it will store its data in an external volume so that we have the ability to mutate the database. That's going to be really important to us. As you might imagine, you don't want a read-only database for a game that might expand. So in later episodes, we'll probably get to do some cool stuff. I think I'm going to have time in this season to actually explore using AI to help build new game boards, and then we'll push the game boards through the API, which, by the way, I haven't drawn yet. So the next thing that we'll actually be building here is an API. And we'll be doing this in Python, so I'll put a little P over it. This will be a REST API that we will build. Representational State Transfer, REST API. Okay, so the API is going to be the way that we interact with our data. The only way into or out of the database is using the API. Once we've built that part, we're ready to actually dig into our front end. So on the front end, we're going to have another Python app. Okay, and I'm just going to put app inside here because this is the Hangman game. Okay, and it's going to use the API to communicate with the database. Now, this is super cool because we get to see all of these moving parts on a very small scale. So that's one of the reasons that I've chosen the structure I have for this, because this gives us the chance to go all the way down these paths, but with an app that's really small. Like if we were going to do this in a large scale production app, it would become quickly overwhelming. Having the idea of Hangman here gives us something simpler to work with. There are also a couple of points that I need to make here in which we're going to use Docker containers around all of the different components. So there will be a Docker container there and a Docker container there to go along with the one for the database. Why are we doing this? Because one of the most interesting parts of using containers is the ability to orchestrate things across a system that goes from the front end through a middle layer to a back end. And so you can build all of this very easily. One of the cool parts of this is that when we get done, it'll be like a one-click sort of operation to spin up the entire application. We can automate the process of bringing up the entire system from the ground. That's really important in large-scale production apps. Now the final component, the sort of iffy thing, I don't know if we'll be able to do this within the season's boundaries, but I hope to, is to actually have a generative AI component inside of this. And I don't know if I'll build this into the app itself, so it could be like an add-on there for AI, or it could be an external AI add-on. I'm still looking at kind of the details there and how that would work. But one way or the other, we'll build in an AI component so that we can explore the idea of using generative tools to enhance our game. All right, so now that we're clear on the plan, we're going to start in the same place that I did in drawing that and build the database container. Let's take a look. All right, so as you can see, I've got a folder here called s2-hangman. This is going to be the project folder for the entire season, so everything will live within this space. The first thing I'm going to do, just to keep things nicely organized, is I'm going to come up here and I'm going to create a folder that I'm calling database. All right. Okay, so you can see my s2-hangman here. We are in that folder and we've got the database folder in place. And I've already created this, but we'll talk through it because this is something you won't have when you start yours up. And that's this .env file. So we're going to use this file as a way to keep track of the global environment variables that are needed by the entire application. Anything we need, we'll push to .env so that it's available for the rest of the application to use at any time. Okay, so what you can see in here, there's two values. There's a username and password. They've got very specific names because they're going to be used later on, and we want to make sure we know what those are. But the long and short of it is these are the root credentials for the Mongo DB that's going to live in our container. We don't necessarily have to be super secure with these. Obviously, I'm putting this on the internet because they are wrapped inside a container, which means you have an extra layer in front of it. Also, this is a really low-risk application, so if you break into my Hangman game, more power to you. I'm really proud of you. I don't know what you're going to get out of that experience. At any rate, if these were actual production credentials, we would obviously be a little more careful with them than we are today. Just keep that in mind as you explore. So the next thing we're going to do is go into the database folder and we're going to create a Docker file. So Docker file is a special word. You can actually see my icon changes to a little Docker whale there. Okay, and Docker files are how you build containers. So containers are instances of an image that's been set up. Okay, and we talked about this a little bit last week. So the idea is that there is a container image for MongoDB that we're going to pull in. And using that container image, we're going to create an instance of MongoDB with special configuration values and what we want to have in it. And so because it's our personal one, it's now our separate sort of sub-image of the original. And then we're going to take that sub-image and we're going to instantiate it, and that's what we think of as a container. It's a running instance of Mongo based on our Docker file. So in order to kick off a Docker file, you start with the from command, and you can see it's helping me out there. The base image that we want to use is Mongo, and we want the latest. So this is the notation for doing something like that. where you can say, give me the Mongo container, and there could be multiple versions, and so I'm asking you for the one that's been tagged as latest. Okay, the next thing we're going to do is pull in those values we wanted to use. So you can see the helper there says env key equals value is the format. So if you remember from earlier, we had Mongo init DB root username, and this equals, we're going to go to our env file and we're going to grab that. Then we have another env, which is Mongo, oh gosh, need to learn to type, initdb root password, and that equals Mongo initdb root password. Okay. Oh, and I have mistyped env, so I need to go fix that. Now, the next thing that makes a Docker container work, obviously we could run this as is, but we wouldn't be able to access anything inside the container because by default, everything is locked about this container. You can start it up, it can do things internally, but it cannot communicate to the outside world unless you allow it. So the next command we're going to use is, I'm really messing up on my typing today. It's the expose keyword. So we're going to create a Docker container, and then we're going to expose a certain port to the outside world. In this case, we're going to do 27017 because that is the Mongo default port. When you run Mongo DB, it runs on port 27017. And so that port we want to allow traffic in and out of the container for. Now, the last thing, we haven't actually told the container what to do. So right now it's going to just start up as a container, but it's not going to be able to actually run any commands yet. So in order to initialize Mongo in our container, we're going to do this. Now, if you've done any sort of command line administration of Mongo before, you probably recognize the Mongo D command. That's the daemon that you start up on your Linux box that says, hey, this is Mongo, I want to start up the service so that the database can initialize. So all we're doing here is issuing that command inside of our container whenever the container begins. So run the container, and then the container says, hey, I'm supposed to run Mongo, and starts it up. So I will save that, and we should be ready to go. Oh, little side note, I do actually have stuff installed here that's reminding me I should be doing Docker container messages in all caps. So all of the Docker commands should be issued in all caps. Just a little reminder. Oops, there we go. And what do we not like about this? Instruction written as a JSON array. Oh, because I used single quotes. I should not have done that. I should have put them in double quotes. There we go. So now we have a perfectly functional Docker container. But we can't really do anything with it. I mean, we could probably try to spin it up on our own, but that's not necessarily going to help us out. So the next thing we have to do is go back to our project root, and we're going to add a file that we're calling Docker Compose. Now this is going to be the way that we actually start our application. And we're going to build all of this from the ground up this way so that it becomes very easy later on to be able to start up and shut down everything that we've built so far. Docker containers can run on their own, or they can run as a series of things that live together in an environment. And Docker Compose is how you compose, all of those containers into a single running unit of work. So in order to do this, we're going to start with the command version, and we're going to tell it 3.8 because that's what we're running currently. Now, inside of our Docker Compose, we have to define services. And each of these services you can think of as sort of the major boxes in my diagram earlier, right? So we have a database box, and we have an API box, and we have a front end box that will all be running individually and doing things. So the first one, and the only one that we've created so far, is our Mongo service. Okay, and to run the Mongo service, we are going to tell it to build everything in the database folder. Okay, so that's the command that we're going to issue when this service wants to start up. Now, the next thing we're going to do is we need to specify the name of our container, because container names are really important when you start to think of how they're orchestrated as a group of things. So we could just let it go without a container name, but it would pick something randomly, and then we wouldn't necessarily know what that container name was. So it's better for us to specify this is what we expect the container name to be, so that we can refer to it later. So we're going to call it Mongo_container, and we're going to give it one parameter here that says restart unless stopped. So this is a little weird because obviously you don't want to restart something unless it's been stopped. But what this says is you can restart the container automatically if there's a crash. If it's not a crash, if it's a manual shutdown that someone issued, then this gives us the ability to just turn it off. And okay, I'm trying to shut this down on purpose. That was intentional. But if the container happens to have a hiccup because something crashes, then Docker Compose will actually track that for you and try to spin up a new instance of that container and replace the one that's crashed. So that's a handy little thing there, just in terms of keeping your system alive. This is how we keep from having to do a bunch of extra manual maintenance along the way. Now, the next thing we're going to add in is the env file. We need to make sure that it's aware that there is an env file that it can use in order to grab whatever variables it needs. Okay? And then oops, I do not want env_file. Thank you, autocomplete, for trying to help me out. Now the next thing we're going to set, we are going to put volumes. Okay? Now, remember we talked about this a little bit on the diagram, that the Mongo container is going to be read-only. And that's terrible for a database because you expect to update the data in the database sometimes. So we're going to store all of our data externally to the container in a Docker volume. This command here is going to establish that for us. Why won't my tab? There it goes. It's tabbing. It took a minute. Okay. So for the purposes of this, I'm just going to build it into the database folder. I don't necessarily want to go to the trouble of, allocating extra disk and things. I'm on my laptop. It's not any big deal right now. If you were doing this in production, you would want to push your Docker volume to some sort of array-based storage or something like that, so that you have the ability to recover from database fault or data faults. That you'll have the ability to have backups and things like that. So you can do all of that magic just by telling Docker volumes where to store its data. But in this case, because I'm trying to keep it simple and we're just walking through an example, I'm just going to put it here in my database folder. And so I'm going to go database, Mongo data, and then I'm going to say that this mounts to /data/db. Now, if you know anything about Mongo administration, that's the default location for Mongo to put its data. So I'm going to create a folder in here with this command called Mongo_data that's going to live inside my database folder, but it's going to be mapped inside the database container to DataDB. And that way DataDB, which is where Mongo is going to naturally write its data, is it's been remapped to this volume. So what we create is this pass-through where the data now lands in Mongo data on the local machine rather than being stored inside the container. All right, so it did it again, didn't it? Autocomplete is really out to get me today. All right, so now we've gotten all of those things done. There's actually one thing left to do before this Docker Compose is complete enough for this first iteration, and that is we have to expose the port. So just like we did with the individual container, we want to make this port visible outside of the Docker Compose environment. So it's one thing to tell the container that it's allowed to have traffic come in, but then you also have to let Docker Compose know about it. So we're going to come in here and we're going to do this, and because we're just using the same default port, it looks like this: 27017:27017. The way this normally works is you have the first number is the port that you will access from the outside, and the second number is the port that you're exposing from inside. So this says if it's mounted on 27017 or if it's running on 27017, I'm going to call it that way. But I could totally remap this at this point, which could be really handy if I have two Mongo databases running on the same cluster of servers, or here on my laptop even. I could run them on separate ports very easily by changing one digit to be a different port number, and then I'm good to go. So that takes care of all that. We've now built the Docker file and the Docker Compose file, and what we're going to do to run these, let's see, I'm going to come down here, and we are in the right folder to do this. So on a Mac, you do Docker space compose up, and then you tell it to build. A little side note, if you're on a Windows box or if you're on a Linux machine, that Docker Compose is going to be hyphenated. It's going to be Docker-compose. The command looks exactly the same otherwise, it just has that hyphen in there. I don't know why Mac decided to eliminate that, but that's something that I actually ran into when I was trying to build this out the first time. It took me a little bit to realize that Mac had changed the command structure there. So, little weird gotcha. But this is the command that'll run here on my Mac, so let's see what it looks like. Oh, and I forgot to run my Docker daemon. So I have to start up Docker Desktop, and you'll see up in the top here I've got a Docker symbol, and I have some things that are running okay, but I don't need Docker Desktop for any more of this because I'm working from the command line. Let's rerun that. And there you go. I have a Mongo container that has now started up. Now, if I wanted to validate this, I could come back here and I can go localhost, and do you remember the port number? 27017. And I get a message that says, it looks like you are trying to access Mongo DB over HTTP on the native driver port. That is a success. That means I have a running container, and I could actually look in Docker Desktop and see that I am currently running a container, a Mongo container. That's the name, Mongo_container. You remember I set that in my Docker Compose file. And so that's all working, and you can see the port that it's running on. And then, of course, I saw the message in my browser that lets me know I've successfully started it up. So we'll stop the container there with a Control-C. All right, so time for just a quick check-in to make sure that we're on the same page, that we've all followed along, and everything seems to be good. Your environment should have a database folder with a Docker file inside of it, as well as a Mongo_data folder that was created automatically when the container spun up. There's also a .env file in your project root and a docker-compose YAML file in your project root. All right, so the next thing we're going to do is initialize the database. Yeah, we got it to stand up. Yeah, the container's running fine. but the database doesn't know anything about the data that we want to store inside of it. So what's that going to look like? How are we going to create a database from scratch? Well, we could totally pull up some kind of tool that would allow us to connect to the Mongo DB and build it out manually, and that would be really awesome. Like, we could set up the whole collection and everything. But one of the things we want to focus on as DevOps engineers is that you should only ever have to do something once. From then on, it's automation that takes care of everything. So out of the gate, we want to train ourselves to think of building in automation rather than doing things manually. So how would we build a database from scratch without ever manually doing it? The first thing we're going to do is create a new file, and we're going to store this in the database folder alongside the Docker file. So if I click on my database folder and I add this in here, I'm going to call it initmongo.sh. Okay, so I'm going to create a shell script that I'm going to use to build my database. Interesting perspective, huh? We've all written shell scripts before, I'm sure. So you start there. Now the first thing I need to do is go get the values out of my env file. So I'm going to do a source command, and I'm going to do env.env. There we go. All right, now the next thing I'm going to do is I'm going to set some variables that I'm going to use as we do this. I'm going to name the database inside of my Mongo. The database name is going to be Hangman. And then the collection name. So the first thing we're going to build is a collection name. Collections are what you might think of if you've done other database work as a table. It's a storage of various records that are allowed to be accessed as a unit. And so it's called a collection in Mongo. So I'm going to do collection name equals phrases. So I'm going to build a phrases collection in a Hangman database. Now, the first thing I'm going to do is I'm going to check whether the collection exists already. This doesn't mean much to us now, but we don't want to reinitialize the database every time that we start it up. It should be here as an automated way to see. So the idea is that if I pull this down fresh from GitHub on a machine that I've never run it on before, I should be able to one click start the Docker Compose, and it will spin up everything in my environment. So how does that look? Well, I'm going to ask Mongo and I'm doing this with my variables, username, and the password. All right, now the next thing I'm going to do is authentication database admin. So that tells it where to go find the authentication for this. I'm going to do it quietly, and I'm going to evaluate db.get sibling db. And I'm going to pass in the name from above. And I'm going to ask it for its collection names. And I'm going to find out if that list includes my hangman or my phrases collection. All right, so there we go. Brief review of this command. We are asking if the collection exists. So the ultimate result of this should be true or false. But in order to do that, we have to ask Mongo to tell us some things. So we're going to call Mongo, and we're going to pass in our credentials. We're going to say, you're authenticating these credentials against the admin database. We're going to do a quiet install, which means don't keep pushing things out to the console. And then we're going to evaluate the following statement. I'm going to do database db dot get sibling db. So given that I'm authenticated against admin, check and see if there's a sibling database named Hangman. And if there is, get the collection names from it and find out if phrases is one of the collections in that database. And that should take care of it all for us. Because now I know whether or not this collection exists. So the next thing I'm going to do is if the collection exists, or if it doesn't exist, is actually more important. Yeah. So if the collection doesn't yet exist, I know I have to do some things. So this will start up and it will say collection name does not exist. I'm initializing it for you. Okay. And so the next thing we're going to do is we're going to say, hey, Mongo. So handy to have these variables defined. We don't have to stop and worry about all of that. We just assume that they're correct in the env. All right, let's see here. So in this case, what we actually want to do is db.getSibling db name, and we want to create the collection. So if the collection doesn't exist, throw a message out that says, hey, I'm about to build this for you, and then build it. And then the last thing in that section we want to do is to inform the user that it has been created. Now, if it has already existed, if it already is there, then the only thing I have to do is just a quick message to let everybody know what happened and say collection name already exists. And that's the end of my if statement. Now, we have a shell script that will initialize our database for us. Pretty cool, huh? The next thing we have to do is make it so that it runs every time the Mongo container starts, because it should check and see. And so that's the idea, is you're going to run this Mongo container, and as it spins up, it says, "Hey, let me validate. Is the collection already here? Do I have the data that I need? If not, I'm going to assume that I'm starting fresh, and I'm going to build it from the ground up. But if it's already there, I'm just going to say, well, that must be the right thing. It must be okay for me to start up without it." So in order to do that, I need to go back over to the Docker file and change just a couple of things to make this work. What we're going to do, first we copy the init mongo.sh into our container. And if you've ever used an initialization script to start up a Mongo before, this is how you do it. By putting it into that location, it will now start up whenever the Mongo service begins. And the other thing I have to do is I have to make sure that that file, because I just copied that into the container, I need to come here. There. Make it executable. So the bash script by itself can't run. It needs permissions to do so. So after I copy it into place, I run chmod to make sure that it has the ability to run on its own. Adding these 2 lines to my Docker file have now made it so that my database can start up. All right, so it's important to note, if you run this container now, you won't actually see the messages that we put in the shell script show up here in this console. You'll have to enter the Docker container to go look at the log for that information. We're not going to dig into that too much right now because it's not really important to the flow of this episode, so that will come probably at a later date when we're doing some troubleshooting along the way. But for now, just know that we've been able to spin this up and we've created a container that builds our Mongo database, that initializes the collection we need if it's not there already, and we've made this completely automatic. Everything is one command away from being spun up on its own. Like I can issue a single command and I get the entire system starting up from scratch. So that's been pretty cool to see, hasn't it? We were able to go from 0 to a working database in just a handful of small commands. This is what makes me so excited about these kinds of tools, because they wield such incredible power in such a small space. And one of the techniques that we have to pay close attention to is this automation, because this automation is the key to all of that. That's the real lesson here today, is that when you're building systems, don't just build them manually. Try never to build manually. Try to always build in a place where you have the ability to automate what you're doing. It pays massive dividends later on. And something else you might want to consider is that if you noticed, we moved from YAML and shell scripting and Docker files and env files. We're like migrating between languages and formats constantly. The role of a DevOps engineer is very much a polyglot. You have to be able to jump between these different concepts fluidly in order to achieve what this system takes to spin up. You know, our traditional IT structure probably would have said certain people are in this domain and certain people are in that domain, and one person knows how to do that and the other knows how to do that. But that's what a DevOps engineer is. It's the role of the glue between all of these different disciplines. So I hope you're enjoying that ride. I know it's a little overwhelming. I'm trying to take my time about it and make sure that I go slowly and explain. So, drop a note in the comments if you need help understanding something. I'd love to hear from you and get to have this discussion. As always, make sure that you click like and click subscribe on the video so that you won't miss any of the future updates, any of the future episodes, because we've got this series that's just now getting started and it's about to get really interesting. So I can't wait to see what you build with this, and we'll see you next time.